3 different organizations were studied to get different perspectives on PTI implementation. Our first example is field packing of zucchini. Product is picked, washed, and packed in the field. Data captured includes commodity, variety, field location, crew, and truck number. The label may be printed in the field and applied directly to the case. This is an example of a mobile handheld computer, a mobile printer, and the label that is applied to the case.
Like to eat linguine and seaweed. I like to eat zambaninis and kiwis. Yep, I'm even eating the skin. Got blueberry seeds in my teeth when I grin. I eat grapes, whether purple or red or green. So I'm the most in shape person you've ever seen. Keep the doctor at bay with an apple a day. Even brought one for my teacher, but I ate it on the way. Whoops. If Dad take me to the store, I'ma tell him what's better than a portobello is a watermelon. What's better than a can of Coke's a cantaloupe. Without a pear, strawberry, or cherry, I can't cope. I could eat apricots till 8 o'clock. I take a walk and I eat the whole raisin box. I know potatoes can shoot and beans make you toot. But for my loot, give me the fruit. Hey! I like fruit!
Now for the shed packing example. Cantaloupe is received from the field location, and crew and truck number are communicated at receiving. The commodity, variety, date, and shed number are also established by the receiving clerk. After the cantaloupe is washed and dried, an automated item labeler applies a PLU sticker that may contain a data bar, the brand, and country of origin. While all cantaloupes share a common PLU number, they are sorted by size or count, also known as grading. In this example, a 110 count case label is being printed with a harvest date encoded into the lot code. The label printer in the packing shed is a high-speed thermal transfer printer which generates the label above. Our third example is a potato repacking operation. Bulk product is received at the repack facility. Information is linked by purchase order, including vendor, receiving location, truck, shipment ID, and receiving date. If the vendor has not already barcoded the pallet, an internal traceability label is generated with a unique pallet ID and is linked to the purchase order. In the future, the pallet ID would be the SSCC number. Each pallet of potatoes is put away by simply scanning the put away location and the pallet ID within the warehouse. When a customer order is received for consumer packed potatoes, a work order is generated and scanned along with the pick location and pallet ID. This links the finished product to the raw product. Individual baking potatoes are cleaned, packed, and identified with a UPC code that can be scanned at retail. The barcode, brand, country of origin, and nutrition information is pre-printed on the shrink wrap label. In the future, these labels may carry G10 and lot number embedded within a GS1 data bar. Other retail-ready packing includes the 10-pound bag with UPC barcode, including lot code printed on the plastic quick lock, which holds the bag together at the top. When the 10-pound retail bags are ready for shipment, they are stacked on a pallet. The pallet label includes the product G10 and lot information, plus the pallet ID, or SSCC, which is linked to the shipment ID. This completes the traceability link from shipment to supplier. Our fourth example is receiving and shipping pre-labeled cases of organic produce from various growers. Eastern Carolina Organics receives pre-packed organic produce with labels identifying the farm of origin, organic certifier, lot number, and product information. The G10 is not used because the traceability requirements for organic produce were established prior to the Produce Traceability Initiative. Product is put away in the warehouse as it is received. Outbound shipping does not require a work order, only a sales order. Barcodes, if incorporated, can be scanned on outbound to link the lot code to the shipment. Now we will discuss the key challenges we discovered as part of this pilot project. PTI currently does not link the item-level data bar to the case for traceability. Location assignment using the GS1 global location number is also not discussed. There are no event specifications for move-in and move-out to enable the supply chain to store information in a uniform way that can be used in an industry-wide traceback. The National Organic Program is not well integrated into the Produce Traceability Initiative. There are no label, material, print quality specifications, or independent testing facilities. The PTI standard has no third-party traceability testing or audit component. Data sharing and privacy are not uniformly addressed. There is not a simple, low-cost way for small growers to participate by purchasing G10s without a prefix. Beyond external traceability challenges, internal challenges also exist. Internal systems generally do not support G10 and lot. Upgrades are expensive, and until all inbound cases and pallets conform to PTI, warehouse systems will need to handle labeled and non-labeled product. The PTI is an ambitious program. It seeks to electronically track over 6 billion cases of fresh produce annually in the United States. Given that the average cost of a case of produce is $5.53, with shipments of 38,000 cases per year per farm, we estimate a basic PTI implementation will cost almost $2,000 to set up, and around 5 cents per label for materials and GS1 fees. This amounts to about 1% of the total case cost. Annually, the cost in materials and fees for PTI implementation is estimated to be in excess of $332 million nationwide. We would like to thank the many pilot participants and contributors to this research effort, and our project sponsor, the USDA Rural Development Fund. For further information, please contact Diane Ducharme at NC Market Ready.